I don't know what they hate on me. They can smell the legacy. Okay, we are live. Oh my god. All right. By the way, there are like premium passes for the tech week.
Oh fuck! Bro, ask your friend, bro. I guess I'm gonna
Yeah,
say.
he only told me that he can give it to me.
Oh, oh, nice then.
Yeah.
Yeah, then for sure, bro. If someone is giving you free passes, yeah, definitely I will put in some money and pull in some
Mhm.
contacts.
Yeah.
And then my contacts would definitely ask me that, hey, can you grab us some passes as well?
hmm I'm gonna ask him like for two, definitely for both of us.
But yeah, try asking if he can get four. If
Four.
yeah,
Who's gonna give him four, bro? Okay, I can ask him. I can ask
yeah.
him like,
Like okay, two is minimum. But if we get four, then that would be better. Better. That's what I'm saying. I'm
who are
fine
the
with
other
two as
two?
well.
Your friend and who
Your
else?
CTO Saab, bro. I don't know if you're staying at this place. Like, we can definitely ask him, hey, do you want to join us? So, like, you
Yeah.
like. So that's why I'm considering four. But if we get two, then that's also fine. Like, they are, I think, rich enough, CTO and ex Amazon engineers.
Let me take a look. How expensive are those?
Same, $650,000, something like that, I guess.
Okay, it's saying it's free.
Oh,
Then I think it's probably the A16G thing that he is talking about. He might be talking about.
okay. Yeah, then, yeah, let's get that. Whatever works. But I think we do have to register over there, right? Or I think they won't get us in. Like, we have to register right now.
On Luma, I think.
Oh yeah, we should get registered right away.
Okay. I think this is the one. Okay, the calendar has not launched yet.
Oh
So I think we should wait for the calendar to get launched first
yeah.
and then book any tickets.
Hmm.
Mhm. All right, let's get back to business. So we were basically on the third point in this forced task worksheet. For the
Hmm.
first two things that we have seen over here are the observation vector. This is basically the dictionary of things or metrics that the robot
Hmm.
observes during the training. that is a set of values which are basically giving it the relative position from the whole for the peg
Mm-hmm.
insertion, the
Mm-hmm.
velocity, linear velocity of the insertion, angular velocity, and what was the other ones?
Angular velocity, linear velocity, and then axis movement, y axis movement, z axis movement, and then we had
Was it that? I don't remember.
no, that was there over there. Like,
Yeah,
oh, you're
this
talking
one.
about this. I thought you were talking about the vector. So finger. So we have like uh,
Position relative to the hole, and then
amount of
fingertip
force,
quad,
that you can apply.
FT force, force threshold, and then the second part was observing the action space over here. So basically, what we were trying to understand here was, yeah, this one, physics state, Isaacson observation pipeline.
Nice.
Neural network interference inference, robot control loop, PP optimization loop, Isaacson physics engine. The fuck are you doing?
Recapture, brother.
Okay, let's focus on the third thing now,
Mm-hmm.
which is the reward terms. So action observation. Oh, now I understand this, bruh. Observation vector, action vector, and reward terms. Okay, so this is something that I did today. Let me show you what it is. Basically, observation and action,
Mm-hmm.
and that is how they are calculating it, I guess. Okay, so this is the notation. Look at this. Oh shit, you cannot. Damn.
Like I was able to see it. Like, what was the thing that like it was in red
No,
and
but it was in markdown. Like they didn't it
mm,
didn't get converted. Okay. Can you see this?
Yes.
So this is basically these are the notation for the research papers that we need to understand.
Mm-hmm.
T is definitely discrete timestamp.
Mm-hmm.
The capital T is number of observed time steps, horizon, observation, or image at time t. So O over here is observation, xt, and it, right? State, st is state at time
Mm-hmm.
t. At is
Mm-hmm.
executable robot action, a t. Okay,
Mm-hmm.
and then these are also like some of the other terms, but for instance, a robot trajectory. So this is very important: trajectory or rollout,
Mm-hmm.
right? A robot trajectory is commonly represented as O0, A0, O1, A1, and stuff like that. And this reads as the robot sees something, O, so O is the observation, and it acts. A is A0 is the action. And then sees the result, then observes something again, and then acts again. So this is how this trajectory works.
Mm-hmm.
And over here, the policy, basically the policy model that we are training is this equation.
Mm-hmm.
Given the robot's observation history and
Mm-hmm.
task instruction. So observation history is O of T, and then task instruction is C.
Mm-hmm.
What action distribution? So this is the thing that we need to calculate. What action distribution should the robot produce?
Mm-hmm.
This is the whole policy model in one equation.
Mm-hmm.
And over here now they are saying over here, this is the observation vector that we are observing first.
Mm-hmm.
This is the action vector. So
Mm-hmm.
this is both O0, A0, O1, A1, or OT, AT,
Mm-hmm.
right?
Mm-hmm.
And then third is the reward terms. Now reward terms is something new.
Hmm.
But yeah, I'm connecting the dots a little by little.
Mm-hmm.
Okay. So factory env def get rewards. So okay, check rods. Some task not threading needs to check rotation alignment for success. Other peg insertion don't just per task flag. What does that mean? Bro, what are you seeing?
I'm not seeing
Can you show
anything.
me?
Like I'm just trying to take a look at what are you looking trying to show me.
Uh, this is the one, right?
Yeah, that's the reward function that we're trying to
That is
generate.
this, but I don't think it's a reward function.
No, like it's not a reward function, but it is the base reward, like
Reward
the
pipeline block by block from both
the
files.
algorithm.
So def this function get reward self check rod blah blah blah. Some tasks not threading need to check rotation alignment for success. One second. Where the fuck did you go? Okay. Core successes per environment boolean is the robot spec fully correctly inserted right now. Compute fresh every step, single step, not just at episode end. Hmm. What does this mean? Core success per environment
Current
boolean.
success,
Is this
current
robot?
success.
So
Upper
yeah,
environment
so this
boolean.
this can only be true or false, right?
Upper environment boolean. Yes, is this robot pack fully corrected inserted right? and computed fresh every single step, not just an episode. And oh yeah, I think this is the final environment result that we're looking for. So if our current success is true, then what it defines is over here is this robots fully correct or inserted right now? Hmm. Or not, like it has to satisfy two things: the robot peg that is fully correctly inserted right now and computer fresh every single step, not at the episode end. What does this episode end means over here?
Oh, I think what it means is, like how it's saying that it runs for like 1,000 iterations in one training simulation.
Mm-hmm.
So I think after each simulation occurs, it's gonna tell, oh, was it a success or not. If it was not, I think that Boolean
Mm-hmm.
factor gets counted into some sort of calculation.
Mm.
Okay, it is still false, still false, still false, stuff like that.
Mm. Makes sense.
Core success, self dot get core success. What is this? Get core success, core engage, self dot. Success threshold is equal to self dot config task dot success threshold. Check rod is equal to check rod. What the fuck? Okay, let's move forward. I think we'll understand it. Okay, reward direct dictionary reward scales is equal to self dot get factory new dict rew dict core successes rew buff torch dot zeros like rew dict kp course for blah blah blah. Oh, calls the function below to get all 7 names reward pieces and their weight. Rew buff starts at 0, then becomes the weighted sum of every term. Term value into term weight. This is the single number, the reward that PPO will actually use or see. Everything before this line is just building the ingredients. This loop is where they get combined into one scalar per robot. Okay. Hmm. Self dot previous actions equal to self dot actions dot clone. Self dot log factory metrics review reward dictionary core successes return rew buff. I think so. Save the steps action as previous for next step. Oh, so this is where it's getting the previous action thing that we were talking about.
Hmm.
This is the one that is feeding into this one.
Hmm.
Where was that plus thing that we were seeing yesterday? This one. Remember? Plus previous action
Oh
appears in get
yes, yes,
observation.
yes, 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 yes. Makes sense. Hmm.
Log individual terms for debugging, monitoring. Example tensor board won't be. Then returns the scalar reward. Factory env.py get factory reward dictionary where the seven terms are built. Get held base position, held base squat, factory meters dot get held base pose. Hmm. Where the peg actually is right now. Okay, this one. Target held base position quad where the peg would be if it were perfectly fully inserted. This is the goal pose, computed geometrically from the fixed assets pose, not measured, calculated. Key point held, tor dot zero, self dot num env, self dot config dot task dot num key points 3, key point fixed, tor dot zero. Mhm. Mm. Instead of comparing just one point, the peg center it scatters several imaginary marker points around the peg shape. Key points offset transforms each one into world coordinate twice. Do you understand this loop?
I'm just going through the loop that we're showing you right now. PPO, gamma, we have tau, 0.95 turns, the sequence of reward into advantage. Was this action better or worse? What is this gamma and tau does? What does gamma and tau relates over here? Guy. Oh, generalized advantage estimation. In PPO robot training, it converts reward from. Wait, let me share my screen so that you can take a look at it well, if you want. Yeah. What the fuck? Wait, dude. When you are sharing your screen, you can also turn on share your system audio. So I guess that's what it was. That's what was blocking your audio stream to come in. I guess.
I never get an option like that.
Dude, I'm getting an option like that. Like I will show you later on. Icon window. Oh wait. What the hell? What the hell is this app?
ChatGPT
Icon. Hmm. But are you able to see ChatGPT or the app icon window?
app icon window.
Now, what are you trying to? What are you seeing? Oh no, I'm not.
Nothing.
Wait, what the hell? Window. Oh, got it. Yeah, there we go. All right. So we have like guy. Are you able to see it clearly? I guess.
Wait, not sharing. Okay. Yes, I'm able to see
Yeah.
now.
So we have guy that the thing that you showed over there. It means generalized advantage estimation. In
Mm-hmm.
PPA robot training, it converts the reward from a rollout into a learning signal for each action. Was this action better or worse? Worse than the value network expected from this robot state. So the calculation starts with a one-step prediction error. Uh, over RT is the reward that after the robot acts. VST is predicted future reward from the current state. And delta T, whether the outcome was unexpected, good plus or bad manners. And
Mm-hmm.
Guy then combines this error with later errors, right? So yeah, this thing is getting complicated. Like I'm gonna say, explain it to a 10-year-old. I do not want to learn that. That's okay. So imagine teaching a robot dog to walk. Each moment the robot chooses something like move left leg forward. Afterward, it gets points. Moving for points for moving forward and staying balanced. Points are falling or wobbling. So PPO guy is like robots coaching, looking back and saying, "Hey, was that leg move a good idea? Better than we thought it would be." If a move helped the robot walk well, the coaches do that more often. If it led to a fall, the coaches try that less often. The
Yeah.
robot also looks at what happens a little later. A footstep might not seem bad immediately, but two steps later, it could make the robot fall. Guy helps connect the later fall to the earlier footstep. Gamma means future points are almost as important as points right now. Tau means look ahead a few moments for clues, but pay the most attention to what happened recently. Oh, oh, I see. This is where the attention mechanism is kicking in, right?
Mhm. Yeah.
So like we have gamma. So gamma defines future points, and whereas tau represents like looking for clues in the future. Like, okay, I guess what does looking for clues in the future means, but pay that most attention to what happened recently. Okay, what does look ahead a few moments for clues means over here? It means the robot doesn't judge an action only by what happens instantly. The robot moves a little too far forward the right way, nothing bad happens. A few moments later, it wobbles, then it falls. So look ahead for clues. Let's the learning system say the earlier foot movement may have helped cause the fall. So the robot gives some of the blame for the fall to actions from last moves, not just very last action. Oh, oh, okay. Now it makes sense. So now, okay. So now, how does the equation works over here?
You're sharing your screen. Just remember that
Yes.
it's on stream.
First, for each robot move, it checks whether the result was better or worse than predicted. So it's gonna be delta t. That is gonna
Upload
be
that
r,
also.
okay, not tau t, and then rt of okay. So v as a robot guess of how many points it expects to learn. Hmm. So example, moving it foot robot expect 10 future points to move. It moves on plus two. But now it expect nine more points in the next movement. So the move went a little better than expected. Then guy looks at the next few and better or worse than expected. And results to AT delta T 0.95 delta T plus 1.995 into 0.95 delta T plus 2. And good word start with how good was my move right now. Did the next move give a clue? It was good or bad. Add a smaller amount after that and keep going and make each further. Oh, I see. Makes sense. So tau and gamma are the two important variables that basically provides our robots a way to figure out okay what's correct and what's not correct.
Mm-hmm. Interesting. What was it? Reward vector or reward terms? Okay, I got it.
Reward points.
I'm going to remove your screen now.
Okay. Oh, you can? No.
Yeah. I mean, from the stream, you can still keep it shared.
Oh, okay, okay. Yeah, I'm gonna stop my sharing my screen anyways. That's fine.
I've written this prompt.
Okay.
Value. Three coefficient pairs feeding the same key point through bell curve function. Three different. Yeah, this is very hard to understand over here. I don't know.
Mm-hmm.
Okay, so I think this is gonna be much better. Okay, so get observation function first develops the 24 number observation vector. Then it puts it in a neural network. And then the neural network spits out seven action vectors, seven numbers. And then this whole goes back into this observation. This action becomes next step's previous action entry. And then this action vector goes to apply action. And then dims 0 to 5 moves the robot. Okay. Saves self dot delta pose, self dot delta yaw, and then get goes to get rewards. And then over here it goes directly to get rewards. Dim 6 saved never touches the robot. Hmm. Reward one number. And what is this? Get rewards is directly connected to this. Okay. Hmm. The action vector gets read twice, once by apply action to move the robot, and again independently by get rewards to grade what was just requested. They're not separate systems. Apply action runs first. Set self dot delta position and self dot delta yaw as instance variables and get rewards called right after in the same env dot step. Uh, just reads those same variables back out. Action vector also loops forward in time. The step function, steps action becomes next steps previous action, which is part of the steps observation. Nothing is thrown away. Okay. One heartbeat of training with real numbers. Let's see. Oh my god. Okay, let's see this if we are able to understand. Physics state ground truth. Peg relative to hole. X, Y, and Z.
BMM.
True wrist force 0.37 newtons. Episode 4 limit. Okay, so these are some of the values. Ground truth. Okay, I think this is the actual value. Like what the peg needs to do to insert, I
Hmm.
think. Observation vector 24 noisy numbers. Fingertip position relatively fixed. FT4s, blah blah blah. Policy, network inference.
Action output, position. We have delta x, delta y, delta z. Then we have roll, pitch, and yaw, and the confidence raw. Action execution, success prediction, policy, success prediction, point 0.4 plus 1. Divide by point.
Bro, I still can't understand this, bro.
What part are you not able to understand? Which part? Like the complete whole
Like,
thing?
no, no, I like get the idea, but like, why is it only giving values? Like, why is it again and again just giving values straight up? I don't know what these values are doing.
Dude, like you are thinking those values as a single vector. You have to think those values as a set of a bigger vector, right? So when you're putting a tensor in, so a tensor won't have a single row of elements. So it will have like a maybe 100k rows or maybe 200k rows like that. And
And what is
then
ENV over here?
env environment, I guess environment 47 peg is 20 mm
I don't
above
think it's
the whole
environment.
above. And then
Like,
I
I
have
know it might be environment, but what is the meaning of environment over here then?
maybe the 47 number, like so you can have multiple different kind of environments. I'm just gonna assume that based on what we know about sim to real thing, right? So I'm just gonna assume that we have multiple types of environment that will basically help you to uh, simulate your peg in different kind of scenarios, maybe like different gravity or something like that. But I would say, like, rather than giving a guess, let's directly ask ChatGPT over there, and it's gonna say, or Cloud Code.
Observation vector, physics state, policy, network inference. Action output, 7 numbers, position delta x, policy success prediction, agent predicts 70% chance of completion, movement control, apply action, target hole, top plus delta position, delta y AW applied to orientation, reward computation, KP find distance, very close to target, point, plus point 0.9, contact penalty force 0.79, Smaller than 5 Newton limit, reinforcement learning. So ReLU is 0, success, prediction error, true start is 0, not inserted, prediction zero point 0.7, error zero point 0.7, penalty for overconfidence. Okay, and then this data is sent to final reward buffer. Total reward zero point 0.9 into distance minus action penalty minus zero point 0.7 config error. Mildly negative. Total reward is zero point 0.9 into action penalty. Distance minus action penalty minus zero point 0.7 config error. Uh, I think the last resort. English. एएनवी का मतलब है एक सिंगल इंडिपेंडेंट कॉपी की सिमुलेशन.
As I said.
यानी रोबोट आर्म प्लस पेग प्लस होल वाली पूरी सेटअप का एक इंस्टेंस.
Fuck, bro. एक इंस्टेंस.
जो आपने आप चल रही है. ऐसा लैब के एक रोबोट ऐसा लैब एक रोबोट पे ट्रेनिंग नहीं करता.
नहीं
वो
करता.
सेम सिमुलेशन की बहुत सारी
बहुत
कॉपीज
सारी
के एक
एक
साथ
साथ
पैरेलल में जीपीयू चला
पैकेज में
सकता है.
चलाता है. क्रेजी शिट
सबका
ब्रदर.
कोड सेम है 4GNV.py. सबके पास सेम नेटवर्क वेट्स है उस वक्त. लेकिन हर एक का अपना अलग रोबोट पोजीशन, अपना अलग पैक की जगह, अपना अलग फोर्स रीडिंग, अपना अलग रिवॉर्ड होता है. सबका अपना अलग अलग ही मजा होता है.
What the fuck, bro?
Hell no. एक सिंगल इंडिपेंडेंट कॉपी यानी रोबोट आर्म प्लस पैक होल वाली पूरी सेटअप का एक. अच्छा ऐसा है एक रोबोट. No, Mactos 128. Oh, num actors. Oh, I see. Num actors. This is the one, bro.
Number of actors. Like, this
We can
defines the
tweak
simulation.
this.
So this defines the number of simulations or number of.
Running at the same time,
Oh,
like at one time,
I
with
see.
different position, different force reading, different.
I see.
Oh, so it's a batch of 128 numbers. Oh, bro, I get it. I get it. Like, not completely, but I get why and why we need to do environment and why we that is the most important part. English, bro. English is crazy.
Crazy shit, brother. Crazy shit.
I wanna die, bro. सबसे पहले फिजिक्स सिमुलेशन होती है.
Mm.
1 second, bro. I'm almost done. I'm just not reading it out loud because it sounds very funny.
Yeah, I know. It sounds like Google or Chat GPT in Hindi. When you talk to Chat GPT in Hindi. Yeah, but I'm trying. I'm also ready to go. I was also going through it. Yeah. Like damn.
I'm not able to understand these two things. I understood this completely now.
Mm-hmm. So what is the part that you're not able to understand?
Action vector
दो बार पढ़ा
is read
जाता है.
twice.
एक बार रोबोट मूव करने के लिए और एक बार रिवॉर्ड कैलकुलेट करने के लिए सेम एनवायरनमेंट स्टेप पे कॉल के अंदर एक के बाद एक.
Okay. Action vector. All right. A concrete example.
सोचो एक रोबोट है एनवायरनमेंट 47 जिसका पेग
Wait, wait,
छोटा
wait.
छोटा
छोटा
सिलेंडर
सिलेंडर.
जो होल हो.
I think one of our friends would really enjoy with this kind of stream.
छोटा सिलेंड्रिकल पार्ट है.
Wait. Are you able to see?
Yeah.
सोचो एक रोबोट है ENV 47 एनवायरनमेंट 47 जिसका पैग छोटा सिलेंडर पार्ट होल जहां उसे फिट होना चाहिए के थोड़े ऊपर है, 20 mm ऊपर. So this is the 20 mm Z,
Hmm.
true wrist force. Alright. और साइड में भी थोड़ा ऑफ. एक्स में -3 mm, वाई एम में +5 mm. पैग हल्का सा टच कर रहा है. फोर्स सिर्फ 0.37 न्यूटन है. बहुत कम, क्योंकि इस एपिसोड के लिए रैंडमली सेट फोर्स लिमिट 5 न्यूटन है. सिमुलेट इस सच्ची स्टेट को 24 नंबर के ऑब्जर्वेशन में कन्वर्ट करता है, लेकिन थोड़ा सा नॉइज ब्लर के साथ, बिल्कुल जैसे रियल सेंसर में होता है. इन 24 नंबर्स में पिछले स्टेप का एक्शन भी मेमोरी के रूप में शामिल है. आई सी, जिसमें रोबोट का कॉन्फिडेंस गैस कम था 20%, जो सही भी था क्योंकि रोबोट तब दूर था. I see. So I think that is the second step. Observation vector is created in 24 noisy numbers. Fingertip position relatively fixed. Fingertip position relatively fixed, -3.1, 5.2, 20.4. FT4 is 0.28, 0.15, 0.18. So, okay, all these 24 noisy numbers are created again. Right. पिछले स्टेप का blah blah blah. नेटवर्क इन 24 नंबर्स को देखकर 7 नंबर्स का आउटपुट करता है. पहले 6 नंबर्स मूवमेंट के लिए थोड़े नीचे जाए, 25 mm थोड़ा साइड में, ब्ला ब्ला ब्ला, रिस्ट थोड़ा घुमाओ. 7 VA. व्हाट इज 7 VA? 7 VA
सातवां
नंबर
भोसड़ी
एक
के,
रो.
इट्स सेवन,
ओ.
सातवां. Satwa, dude, it's not 7 VA, it's Satwa. You have to go in the flow. Satwa number एक raw confidence score है. It's not 7 VA.
क्रेजी. ये 7 नंबर्स दो अलग फंक्शंस में यूज होते हैं. अप्लाई एक्शन पहले 6 नंबर्स लेकर रोबोट को एक्चुअली मूव करता है. और साइड इफेक्ट में सेल्फ डॉट डेल्टा पोज सेल्फ डेल्टा सेव कर देता है. ओके. Action output 7 numbers. So these are the 7 numbers. And then one is the confidence score over here, point 0.4.
Mm-hmm.
And then action execution. So it uses the apply action, target, hold, top, delta, position, delta, yaw applied to orientation over here. And then अप्लाई एक्शन पहले 6 नंबर लेकर रोबोट मूव करता है और साइड इफेक्ट में ये रिकॉर्ड करता है कि कितना मूव एक्चुअली मांगा गया था क्लिप होने के बाद. जो तुरंत बाद चलता है 7वें नंबर को रीस्केल करके 70% कॉन्फिडेंट बना
बना
देता है.
देते
और
हैं.
वही सेल्फ डॉट डेल्टा प्लस डिवाइड बाय सेल्फ डॉट डेल्टा या वापस पढ़ लेता है जो भी अप्लाई एक्शन ने बनाया था. अपग्रेडिंग होती है होल के पास होने की वजह से स्ट्रॉन्ग पॉजिटिव रिवॉर्ड मिलता है केपी फाइन प्लस हल्का पॉइंट जो कम है इसलिए आर एल यू फोर्स थ्रेशोल्ड जीरो आता है कोई पेनल्टी नहीं कॉन्टैक्ट बिल्कुल ठीक है लेकिन असली कैच ये है कि रोबोट अभी तक एक्चुअली इंसर्ट नहीं हुआ है ट्रू सक्सेस जीरो और उसने अभी बोला कि मुझे 70% कॉन्फिडेंस है कि मैं हो गया ये एक बड़ा मिसमैच है जिसकी पेनल्टी लगती है टोटल मिला जुला के रिवॉर्ड डिसेंट है क्योंकि की पोजीशन अच्छी है लेकिन ओवर कॉन्फिडेंस की वजह से काट दिया ओवर कॉन्फिडेंस की वजह से काट दिया गया मूवमेंट की वजह से नहीं ये रिवॉर्ड एक सिंगल नंबर और स्टेप का एक्शन let me see what people are watching. No one is watching. Fine. और एक सिंगल नंबर और स्टेप का एक्शन दोनों आगे कैरी होते हैं एक्शन अगले स्टेप का प्रीवी एक्शन बन जाता है जो अगले ऑब्जर्वेशन का पार्ट बनेगा और पूरा साइकिल फिर से रिपीट होगा I see bro now I get the whole picture English for the win bro
Nice. 7 VA. That's called Satwa.
सातवां and सातवें
Hmm.
so let me just see this okay success prediction 70% policy prediction. How did it come up with 70%? That's my only question.
Where is it saying 70%?
This one policy success prediction zero point 0.4 plus 1 divided by 2 is equal to. How is it doing this math?
But that is an arbitrary number, I would say that. It's not a successful math over there.
No, but it's the logic should be same, right? Like there should be
No,
some
no,
logic for zero
no,
point 0.4 plus 1
that's a
because zero
prediction
point 0.4
math.
is the confidence score over here.
Right. No, 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 no. That I know, but I'm saying the final prediction score.
Because zero point 0.4 is the confidence
Dude,
score
it's
generated by the neural
dude,
network,
it's
and
taking
that is
point
being
four.
calculated with some sort of
Dude, it's taking
success
average, I
prediction
guess. It's taking average, I guess. Point 0.4 plus
of
one.
what?
Of those two numbers, 1.4.
Confidence is zero point 0.4 and the success is 1, right? 0 or
Yes,
1. So success
yes.
is
And
1.
and then you divide it by two, you get point 0.4, 0.7.
Oh, 70%. Oh, yes, that
Yeah,
makes sense. Yes,
yeah.
yes, yes. Success prediction is zero point 0.4. Oh, wait. Why is it not 40% then? If the confidence is zero point 0.4?
Dude, what do you mean? How will it like? That's why we're taking the chance of success as well, right? Like if it is success, if it has a success, otherwise it should be like definitely it should be 40%. But that is a raw confidence. It's not computed confidence. That is a problem over here, I guess. Because like okay, even if you have a 40% chance of doing something correct, right? What is the final outcome? The
Hmm.
final outcome is defined by if like as it said over there, success outcome, the boolean variable that we have, did the peg went inside the hole or not, right? Did the peg went inside the hole or not? That's how it is trying to compute it. So when we are trying to compute a prediction, right? So we have to take in account of our confidence and as well as whether we had a success. So if we have 40% chance and we are looking for only a success parameter that is gonna be only one, because zero or one, that's how we define success or failure. That's why I guess we are.
Hmm.
That's why I guess it's taking an average over there, like point 0.4 plus one. I don't think that that is an accurate average or a accurate way to do it. But yeah, like for time
Hmm.
being, it kind of makes sense. Like if you're trying to understand something over there.
Hmm. I see. All right, bro. I think we should continue tomorrow because
Okay.
I'm gonna
Oh,
die.
All right, bro. So yeah, that was fun. We got to learn more about how our algorithm
Yeah,
works.
no, this was
And
like super clarifying.
yeah, 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 yeah. Like in a fun manner, though. Like I would say.
Yeah. Wait, I'm gonna end the stream, but don't leave the room yet.
Mm-hmm.